Welcome to this podcast brought to you by the Vatican Observatory Foundation. I'm your host, Bob Trembley. I'm a volunteer NASA JPL Solar System Ambassador, the president of Michigan's Warren Astronomical Society, and an internet factotum for the Vatican Observatory Foundation. This podcast comes from a recording of one of our monthly full moon meetups with the Vatican Observatory staff and Sacred Space Astronomy subscribers. Sacred Space Astronomy is the Vatican Observatory's online community. We have several astronomers and scholars who write articles on our website about astronomy, space science, and faith in science. Every full moon, the Vatican Observatory Foundation hosts a Zoom meetup for our Sacred Space Astronomy subscribers. Typically, our guest will be a member of the Vatican Observatory staff or an affiliated researcher, and they'll tell us about the research they're doing and the journey that led them to the Vatican Observatory. Brother Guy Consolmagno, director of the Vatican Observatory and president of the Vatican Observatory Foundation, will typically talk with our guest, and our Sacred Space Astronomy subscribers can ask them questions. The audio for this podcast was taken from the Full Moon Meetup on Tuesday, January 25th, 2024. Our guest was Dr. Michelle Francl, the Frank B. Mallory Professor of Chemistry at Bryn College in Pennsylvania, and she's an adjunct scholar for the Vatican Observatory. Dr. Francl was a guest for the Vatican Observatory podcast in December of 2021 with the episode A Taste for Heavy Water. The link is in the description. This time it's a somewhat more familiar drink that will be the topic of discussion. Michelle will be talking about her new book, Steeped, The Chemistry of Tea. Steeped explores the chemistry behind different styles of tea, from green tea to pu'er. It tackles the age-old question of when or even whether to add milk, and it puts the chemistry to use with advice on how to brew a better cup. I have to say, when I was editing this podcast, there were several points where I was just cracking up.
Well, it's great that you guys can make it, and I don't know if you've been seeing the New York Times or the Washington Post or the Daily News, depending on what your newspaper of choice is, but our guest today has been featured in all of those as of yesterday. So, Michelle, tell us, how did that happen?
I wrote a book, and the book got published yesterday, and the Royal Society of Chemistry, who's the publisher, sent...
What's the title of the book?
The title of the book is Steeped, The Chemistry of Tea. And so the Royal Society sent out a press release that had one line in it that mentioned that there was advantages to putting salt in tea. And the Daily Mail picked this up and interviewed me. And then I went to bed, and the next morning I woke up to a firestorm in Britain about salt in your tea, which included weighing in by the U.S. Embassy. And so yesterday I spent a lot of time talking to people on the BBC and other spots and the New York Times. I haven't even seen most of it, but it was a pretty crazy day, and today is shaping up to be about half as crazy as yesterday, which is a great relief. But it's interesting to see when tradition and science come head to head, where people come down.
So tell us, how is it that you, of all people, wrote this book? Who are you that you should be writing a book about the chemistry of tea, and why for nature?
Right. So here we go. So it really was a tweet that kind of got it started, and a little bit a research project from about almost a decade ago. But the tweet was, somebody wondered about the shape of tea bags. The chemist wondered about the shape of tea bags. Did they really matter? Like the little cute tetrahedral things, the flow-through tea bags, does any of that matter? And which made me wonder, what did chemists know about making tea? And because I write this regular column for Nature Chemistry, I'm always kind of on the lookout for interesting stuff to write about. And so
you should start by mentioning what your day job is.
Oh yeah, so my day job is professor of chemistry at Bryn College. So I teach quantum mechanics and I teach intro chem, and my research interests are molecules that misbehave, that have structures that chemists would not anticipate. So I'm really interested in the relationship between molecular structure and function, and that's related to this whole book piece too. So I went ahead and wrote a little essay for Nature Chemistry. I looked at the literature and wrote 2 pages about, what do chemists know about making tea? And it was written for chemists. And then the pandemic happened. So this came out about a week before the pandemic really broke. When the pandemic broke and we were all locked down, Nature sent it out to their mailing list. And an editor at the Royal Society of Chemistry saw it, sent me an email, said, loved the essay. Could you turn it into a book for the general public? So now she's asking me, can I turn 2 pages of an essay written for chemists into, 200 pages for the general public? And I was like, I have no idea. She says, oh, well, write me a book proposal. But of course, it's the pandemic and I'm teaching. So a month later, she sends me an email. She said, did I scare you off? I'm like, no, I'm just drowning in, I was department chair, so I'm trying to run my department in the middle of a pandemic and teach online. So the semester ended and I wrote her a proposal, and turns out, sure, I could turn those 2 pages into 200. So I spent the last 3 years kind of digging through the literature. I read over 500 pages, drank over 400 cups of tea, and really thought about how to explain chemistry to non-chemists in a way that would not make people's eyes glaze over, but to really enjoy, what's happening at the molecular level. So that's kind of the story of how it came to be.
What were some of the surprises that you came across in the research? What was unexpected to you?
So the biggest unexpected thing to me was what caffeine does for the plant. Because of course the plant does not make caffeine to help humans stay awake, right? The plant makes caffeine for its own purposes. And it turns out caffeine it makes as a herbicide and pesticide. So, the world's favorite psychoactive drug turns out to be a pesticide. If you think about that too hard, you might think twice about your coffee or tea, or maybe not.
Wonderful. What did you actually determine about the shapes of tea bags?
So it turns out the shape doesn't so much matter as the size. And this comes back to research that Brother Guy has done. You need to have enough room in the tea bag for the tea leaves to expand, and they expand by a factor of 4 to 5, so it's quite a bit. So if they're packed in a tea infuser, if they're packed into a tea bag, they wouldn't expand enough, and you won't get good access of the solvent to extract the compounds you want from the tea. So it's really about the size. It turns out those tetrahedral bags, because they're closer to spherical, you've got a lot of surface area relative to volume. So that tends to help.
But the famous Lipton flow-through bag, that's mostly a marketing gimmick?
It turns out, no, the flow-through bag is pretty good because you've got sort of 2 sides to it. So you've got 4 sides of access. The little round pillow things are the worst. But again, you don't generally have too much choice in that. If you make your tea, though, from loose tea, which is what I like, you use a tea basket or an infuser. And here you should use a really big one. And they make all these cute little adorable ones that are, about yay big. And the volume just isn't large enough. And I measured the volume of a bunch of them. And this presented a challenge because tea infusers are meant to have water flow through them. So you can't just fill them up with water to find out their volume. But it turns out that some Jesuit scientist had a good trick for this. There he is waving at us. Brother Guy was trying to measure the density of meteorites, which meant you needed their volume. And you don't want to dunk those in water either. And here we get a coffee tidbit. In Italy, the sugar you use to sweeten your coffee is fairly large grained. And it suddenly occurred to this Jesuit scientist, who is in the corner of my screen, that maybe you could use that as the fluid to measure the volume. And sure enough, there's a lovely published paper, which I cite in the book, about doing that. And I got myself a bunch of glass beads and measured the volumes of these infusers. And I can tell you that the cutest infusers on my shelf are the most useless.
I remember you saying there was another Jesuit connection to tea in terms of names.
Yes, and it's another Jesuit brother. So in fact, the official name for the Linnaean name for tea is Camellia sinensis. So the camellia that comes from China. And camellia is named for the Jesuit pharmacist, George Kamel. And in fact, I have a picture of George. So maybe I'll share my screen for a second and show us what George looked like. He was a 17th century Jesuit who was missioned to the Philippines. There we go. I'll say something about that picture in a minute. But there is George Kamel. And George was, as I said, late 17th century, and he was inveterate at trying to inventory the pharmacopoeia of the Philippines. What plants were available. This was the main source of medicines. And so he sorted through all these plants. He documented them. So in fact, he drew lovely pictures. I should be able to show you. There's one. So this is a picture hand-drawn by Kamel of a camellia plant, though it was not called a camellia, because camellias are named in honor of camel. And Linnaeus actually didn't have a great opinion of camel, in part because these drawings never really made it to Europe until long after Camel was dead. So he's one connection. I mean, there's a couple of interesting other connections from him, which is that he was born and raised in the same place that Gregor Mendel did his work. So Brno is a spot that's led to a lot of interesting religious scientists. And the other piece is that he worked on something called St. Ignatius's beans, which are a source of strychnine. And they were the source from which strychnine was first isolated. And that led to techniques which enabled them to isolate caffeine and quinine, characterize them, and eventually synthesize them. So there's kind of a whole series of links between the Jesuits and tea.
So, getting to the heart of the issue, what's this I hear about salt in tea?
Ah, yes, if you have seen the news, you know about salt in tea. It turns out there's an 8th century Chinese manuscript called the Book of Tea by a Chinese tea master named Lu Yu, L-U-Y-U. And in it, he has a very detailed set of instructions for making tea. They parallel what we do in making modern tea. But one thing he says that we don't say is he says, add a little bit of salt to the water after it boils. And my chemist ears went up and I'm like, why would you do that? I mean, clearly it was doing something for the tea. He doesn't say what. And it got me to kind of plunge into the chemical literature again. And this time it's the literature on coffee. And the coffee people had noted that if you add a little salt to the coffee, it makes it less bitter and makes it a smoother drink. And they wondered why. And it turns out the sodium ions in the salt block the receptors for bitter. And so the sodium ions sit in those receptors, and now you can't detect bitter as well. And so it makes the tea or the coffee less bitter. And it's not even enough to taste. Like if you put in enough salt to taste, it's too much. And so I did some experiments, and sure enough, if I let my tea overbrew and get a little too bitter, tiny bit of salt will make it drinkable.
How much is a tiny bit?
Oh, like, pick up a pinch in your finger, and that's really all of it. Don't scoop it up in a spoon. Apparently some British show yesterday was putting spoonfuls of salt into tea and saying, boy, this tastes terrible, which doesn't surprise me. But then I had a host last night, 2 hosts tried it, and they actually asked me how much, and they, took the salt and right on screen, put a little bit in, and noted that, yep, it did seem to, fix the bitterness. So
who knows? Does this have anything, Paul Gabor is asking, is this the reason why chocolate may have salt added to it as well?
it probably is. And I think it's probably why you end up with salt in a lot of things. You can have like salted caramel. I think the salt in brown butter sometimes ameliorate some of the bitterness you get, when the butter browns. And somebody wondered if when you take Paxlovid, which is notoriously bitter, if you take that for COVID, would, taking that with a grain of salt, literally, in fact, ameliorate that? And that's a really good question, and I don't know the answer to it.
One thing you've just said has got me interested about an 8th century book on tea. So what can you tell us about the history of tea? Who were the first people to brew it, and how did it wind up in Britain?
Oh, that's a long story, and I won't tell all of it, but I will say trying to trace back the beginnings of tea is really tough. No one has been able to find a wild tea plant. It's all cultivated stuff. There's feral tea plants, which have escaped from plantations, but no one's ever found one in the wild. So trying to identify where the tea plant originated, even geographically, has been tough.
Ancient astronauts, clearly.
Clearly, absolutely. And then you think about like who first thought about taking leaves, drying them, and putting them in water, extracting them, and then drinking the solvent, right? That's how chemists would view it. It turns out that animals do this. So animals will chew up leaves and apply them to injuries. So this notion that you can extract something with something, liquid, and use it pharmaceutically is really an animal behavior. Primates do it. So people have been chewing on leaves for a long time, and it's a short step from chewing on those leaves to saying, well, maybe I don't want to chew on them and spit them out. Maybe I want to soak them in some water instead to the side. So it's kind of linked to the development of containers. So it's linked to the development of pottery. And so, now you have, beautiful teapots and things like that, but the ability to like make a container and soak stuff is linked to that. So the first sort of references to tea date back more than 2,000 years, so before the time of Christ.
One thing I remember learning my time in Kenya when I was back in the Peace Corps, there were coffee plantations and tea plantations in Kenya.
Yep.
And coffee was easy. You pick the beans, you lay it out in the sun for a few days until they're dried out. You put them in a bag and ship them away. But tea has to be picked and chopped up and dried and processed almost immediately.
Yes.
Which makes me even wonder, how did people do it originally?
Right. Well, I think people originally, you can just pick the tea fresh. And if you pick the tea fresh and throw it into water, you will get the caffeine out. And so I think that might have been the first draw to it. But now I have a big flow chart in the book that shows the chemistry of like the 8 different steps that you go through. And depending on how you do this, you get different kinds of tea out. But you're right, you have to pick it immediately. You have to be very careful not to bruise it, because if you do, you release enzymes that will prematurely oxidize the tea. So it's a really complicated and incredibly beautiful chemical processes that are involved.
When you say beautiful, is it just that it's complicated, or that there's something really special and unique happening in the chemistry, or a little bit of both?
A little bit of both. To me, what's the interesting part about it is how the tea producers are marshaling the chemistry within the cells. So, if you take the tea and bruise it, you release these enzymes. So if you want the tea to be black, you want to release those enzymes. If you want the tea green, you want to kill off those enzymes. So you very quickly heat it to destroy the enzymes. And the really fun thing is pu'er tea, which is not terribly bitter, is made using microbes to do the chemistry. So you deliberately infect it with the mold and let the mold do the work, processing the tea. And the mold is the same mold that you find, that black mold you find on onions. So if you have onions in the pantry and you pick it up, sometimes they have a little bit of black mold on them. That's Aspergillum niger, which was identified by a Florentine priest who was a mycologist. And he named it Aspergillium because it looked like what you use to, dispense holy water. And so I love that connection, but I really love that, one's marshaling other species essentially to do the work for you.
Now, how do you make smoky teas? Liplops and sushi and things like that.
Right. If you like that, you put it over smoky fire. Same way
Really, it actually is smoke.
Yeah, it actually is smoke. And
I never knew that.
Yeah, and so teas can be smoked. Teas can be also flavored with other things. So you can put jasmine in or rose in. And the same thing, you kind of stir it up, let the compounds exchange with themselves, and then sometimes remove the jasmine from it. And you just kind of float your tea leaves over the smoke and gently smoke them and let them pick up those other compounds.
Now, I'd read someplace that they're possibly carcinogens because of the smokiness. Is there any truth to that, or who knows?
There's tons of carcinogens in tea. And as soon as you heat something up, you start producing these molecules that can give you that are carcinogens. So if you're heating tea generally to kill off these enzymes or to dry it, and you're already producing things like acrylamide, which is known to cause cancer. As one of my colleagues who studies this says, living causes cancer. And so, and all these things are in very small amounts in the tea. So the other thing chemists say is the dose makes the poison. And really at the levels these things are in the tea, it's not something to worry about. The health benefits are kind of clearly outweigh the risks.
What are the health benefits?
Oh, the health benefits are caffeine turns out to be neuroprotective. So people who consume more caffeine have lower incidences of things like Parkinson's disease. So that's an interesting, to me, piece of things. The other things are that you have all these antioxidants in it. So you have all these molecules that essentially have these little hydroxide groups on the end, like fingers, that will help to scavenge oxygen. And oxygen is good when we breathe it, but not so good sometimes when it's floating around in our cells. So you want a way to scavenge that up. And a lot of processes that lead to ill health are kind of kicked off by having too much oxygen in the cells. So antioxidants are good.
Well, there is one other ingredient to tea that we haven't talked about yet, which has an astronomical connection. In fact, the largest ingredient of tea, which is
water. And
what did you find out about the chemistry of the water?
well, I mean, the chemistry of the water is interesting. I mean, one of the things I did, and this was kicked off because I went to the summer school for the Vatican Observatory about water in the solar system. And which got me thinking about, where did the water on Earth come from, right? Is it, crashing from comets? Is it, come from the Earth when it's originally formed? Is it allochthonous? And how old is the water in the universe? And so that kind of led me to trace things back. And within a few seconds after the Big Bang, you have hydrogen, you have protons. So if you look in your water, in some ways, you're looking at stuff that was made at the Big Bang. And that's kind of crazy. It's 13 some odd billion years old, the water floating around in your tea. The oxygen's a little older, but that's got the protons from that Big Bang too. So, to me, it's kind of stunning to think about how ancient the water is, but also water is really, as a molecule, really flexible. So it'll like hand off those protons. Here, take a proton, have a proton. So water is changing over every few milliseconds. So when I wrote a piece about the history of water for Nature Chemistry, I wrote that water is ever ancient, ever new. And I knew that my child's Jesuit education had taken when he and his friends read the piece, and he said, "Oh, you're quoting Augustine." I thought, all that tuition was worth it. Good job.
So what effect does having the right kind of water have on the making of the tea?
Right. So what you want is water that's pretty pure. And so Lu Yu writes about that, don't take it downstream from the village. He's echoing advice that you hear from Hildegard of Bingen in her writings too, where she's, if you want to use water to make some kind of tincture or some kind of herbal tea, definitely don't take it from the swamp. She says don't use dirty snow. It's important that the water be clean. And it's important that the water be as free of ions as you can get it. So this is my teacup looking down on it. It looks a little galactic. It looks like a galaxy. And I'll say one thing about it. There are as many molecules in that cup of tea as there are stars in the universe, order of magnitude. So, we think about the vastness when we look out into the universe, but there's also the vastness in that cup of tea. And there, it looks like that little galaxy floating on top of it. That is what is known as tea scum, which is related, alas, to the scum in the bathtub too. The formation of this is started by magnesium ions. The magnesium comes from the tea itself, but also comes from hard water. And that raft of stuff contains the antioxidants and some of the flavor compounds. So what you've done is kind of, sieved out some of the good tasting stuff and some of the healthy stuff. And now it's floating on the surface of the tea. So the tea does not taste as good. So it's important to use water that's not too hard if you can get it.
If I were making tea in Italy and I've got, tap water and I've got filtered water and I've got bottled water that has all sorts of wonderful, good tasting ingredients, what do I want to use?
You want to use the filtered water. Tap water is second. I use tap water at home. The water in the chemistry department here is like so hard. It's crazy. And you can see the difference in the color of the tea. It will make a much darker tea if I make it at work than if I make it at home. So sometimes I just bring water from home.
But does it make sense to use distilled water or deionized water?
Yep, if I'm willing to walk down to the biochem lab, I can get distilled deionized water, and that will make really nice cup of tea. The trouble is, if I do that, the chances of getting caught by a student along the way are fairly high. And then I get distracted having a conversation, and by the time I get back, no time to make a cup of tea.
Wonderful. Well, what is your favorite cup of tea?
My favorite cup, I have two favorite cups of tea. My favorite cup of morning tea is an Assam tea, which is a very black tea grown in India. It generally has a lot of caffeine in it. Good morning, that's what I really want. But it also has a great kind of floral scent to it. So it's, kind of nice if I close my eyes and take a deep breath of that in the morning. I can imagine myself on some mountain hillside, lots of flowers around. It's a very soothing way to start the morning, but it has the benefit of all that caffeine. In the afternoon, one thing I like is something called green snail tea. I will assure you no snails were harmed in the making of this tea. It's a green tea and it's rolled, so they look like tiny little snails. Lower in caffeine, also pretty aromatic, somewhat sweet. That's another kind of interesting piece to it. There are sugars in the teas that are naturally occurring. The green snail tea is pretty sweet.
How many of you people attending here are regular tea drinkers? Raise your hand if.
Ah, great.
Yeah. You say you do sometimes drink coffee.
I do, but only when I'm in Rome. And I mean, it's, the 10 o'clock, coffee hour at the Specola was not to be missed. And, if a good barista is going to make you a good cup of coffee, you should definitely, when in Rome, do as the Romans, and drink it. So that's the one place I do. I grew up in the Midwest where everybody drinks coffee. My parents drank coffee, my aunts and uncles drank coffee, and somehow it never took with me. But Rome has given me a new taste for coffee, I have to say.
So where did you get your taste for tea?
We were camping and my mother gave me a cup of tea. It was cold outside and she was making tea. I don't know why she wasn't making coffee. That's actually a question I wish I could ask her.
How old would you have been at this point?
I would be like 7, 8, something like that. So pretty young. And she put a lot of sugar in it, so it was sweet and it was hot. And I felt very grown up. My mother was giving me a cup of tea. I started drinking tea in the morning before I went to school after that. I would, make my cup of tea on the stove and do it. And I've ever since drunk tea.
Are your sons both tea drinkers?
My one son is a tea drinker, the one who lives in London. So it's good he's, assimilated well, because he is a tea drinker. My other one drinks coffee in the morning and tea in the afternoon. When he's home, we have all the fancy coffee making equipment. He went off to graduate school at Ohio State and we had company and I went to make coffee and I realized he had taken away the coffee grinder, the little scale for weighing things, the filters, it was all gone. So now I've had to restock coffee making equipment. And he said, I wondered when you would notice.
And what about your mathematician husband?
He doesn't drink coffee either. He drinks tea, but he commits the cardinal sin of reusing the tea bag. And I point out in the book that people have studied this, right? They've, extracted used the tea bag once, twice, 3 times. After one use, there is no more caffeine left. Forget it. After 2 uses, there's really no more antioxidants left. And what you're getting is sort of just colored water. But it turns out that Victor is perfectly happy with a cup of colored water with a dash of milk.
When I was in grad school, there was a fellow grad student who was poor as a church mouse because he was married with a small child and trying to live on a grad student salary. So he would try to get by with 1 tea bag a week. The difficulty did not stop there because after every use, he would rinse it off under running water.
Yeah, he was not getting what he wanted out of that tea bag, I guarantee you. If you have a small child, that caffeine is really, something you might really want.
Indeed. So I'll ask the bigger question. How did you get involved with the Vatican Observatory?
Oh, well, that is a probably shorter answer than the history of tea. So I was working on another book, which in the end did not fly. There was a downturn in the economy and the whole imprint the publisher had got pulled. So the book never appeared. But the publisher invited me to go to Sci-Fu at Google, which is an odd collection of people in an unconference forum. And I was talking to a Jesuit friend and he said, what are your plans this summer? I mentioned—
Wait. How do you have Jesuit friends?
How do I have Jesuit friends? I made the spiritual exercises of St. Ignatius I don't know, many years ago. I regularly would go to Wernersville, which is the old Jesuit novitiate outside of Philadelphia that, again, somebody in this call I think knows and has spent time at. And so I would go out there once a month to see my spiritual director, talk about, prayer and science. So I had Jesuit friends out there. And Lucian Longton asked me, what you doing this summer? And I said, going to this, crazy thing called Sci-Fu. And he says, oh, one of ours is going. And he gave me a description of Guy.
You should, for those of you not familiar with the Jesuits, that phrase, one of ours, the word our is capitalized.
Ah, yes.
It indicates a fellow Jesuit. But anyway, continue.
Sorry, yes. I've lived too long at the edges of Jesuitness. So he gave me a very good description of Brother Guy, including the beard and the fact that he talked a lot. And I got on the bus from the hotel to go to Google, and there was a guy literally sitting across from me with a t-shirt on that said, "Ask me about my vow of silence, talking a mile a minute." And I thought, and with a beard, and I thought, this is Guy Consolmagno. So I introduced myself and we met.
And I was shocked at the number of people we had in common, that we knew in common.
Right, it was kind of amazing that we had never met before. Then on Sunday morning, we decided we would go to Mass. And so Guy had tracked down a place to go to Mass. Neither of us had a car. So we walked. And was it about a half an hour each direction?
Something like that, yeah.
It was a long walk. So we had a lot of time to chat and get caught up. And so that really started my relationship with the observatory and its astronomers. And then Guy became the director. And on the same day the Pope was visiting Philadelphia, I got an email from Guy asking me to think about whether or not I would want to be an adjunct scholar of the observatory.
And I'll explain, it's not just that you're a scientist. Your science is not really directly astronomy, but the Vatican Observatory has two tasks, one to do the good science and the other to show the world. And you had, and still have, a very active apostolate of science and theology. Can you describe some of the things you do at Bryn Mawr about spirituality and science?
Right. So I maintain a blog, which I've written now, I think, for about 20 years, called Quantum Theology, which sort of looks at the intersection of the lived experience of a scientist and the lived experience of faith. And, includes stuff about my kids and other things like that, but it's sort of a fullness of life. I teach a couple of courses at Bryn Mawr, one of which is called Contemplation in the West, and another which is called Women Who See Through Walls. And the course Women Who See Through Walls is about women scientists, women mystics, and for ways to think about how these things intersect. So we read Hildegard of Bingen, for example, and we think about the ways in which people think about truth, look at the world. The course on the Contemplation in the West is a traveling course. So we go stay at monasteries in the US, but we also stay at Buddhist monasteries in Japan. It's the ultimate field trip, 2 weeks in Japan with 15 students. We visit hermits living in the mountains. And again, thinking about the intersection between the natural world and faith, and how do you, seek God in all things, but particularly in the things you encounter in the natural world.
You mentioned a couple of times Hildegard of Bingen. So remind us who she is, when she lived, what she did.
So Hildegard of Bingen lived around 1000 AD, and she was a Benedictine nun, and she was very active in thinking about not only matters of faith. So she has these beautiful mystical writings, but she also has very practical writings about, the natural world around her. She's descriptions of fish and the ecology, what were the marshes like, but also she has a pharmacopoeia. So she talks about, what you might use if you're anxious. She talks about making particular kinds of cookies that would be, healthy to eat. She talks about various teas. She's interested in water. She also has some ideas about evolution. They're kind of crazy, but she's starting to think about how does stuff come to be? And I think that's really part of what science is interested in. How do we get from where we were, nothing, to where we are now, a lot of something?
I was going to say, what was the reaction of the church to her now, and who's been pushing her cause lately?
So she's finally been sainted, and she has been declared a doctor of the church. And I'm going to say, I think it's John Paul, but it might be Benedict, who said when he made her a doctor of the church, talked about how he wanted to not only forefront science as something that is part of the work of faith, but also women scientists. And that's very specifically mentioned in the documents, that she's, sort of held up as someone that we would like to look to, that says that women can do science and that people of faith can do science, that religious scientists are not an oxymoron, but something that we value in the church.
So this all comes back, your work in outreach, your blog, the writings you've done. You've written a number of articles for Give Us This Day. You've written a number of books now, some that actually have gotten published finally.
Yes. Yeah. So right. So the T book is my 6th book, 7th if you count the audio book. So maybe we should say that a lot of the information about the Catholic scientists came from a series that Brother Guy and I did how many years ago? 5?
Before COVID, therefore BC.
All right, so before COVID, we both had terrible colds. That's what I remember about doing it. But we recorded a 12-part audio series about 1,000 years of Catholic scientists, which includes George Kamel and Hildegard of Bingen. And at some point, maybe my sabbatical next year, we turn it into an actual book. But it was a really fun set of conversations to think about scientists of faith.
Which then brings me back to the last 2 days that you've had, interacting with the public, interacting with newspaper reporters. What are the sorts of questions do they ask? Do you ever get to show the Jesuit connections? Do you ever get to talk about your own personal tastes in tea? What do they seem to want to know?
Boy, it can be all over the place. So I did an interview with the Philadelphia Inquirer, who was very curious about the relationship with the Vatican Observatory and asked about that. Some places get very fixated on this business about the salt and nothing else. Some people want to know why it is that I'm so interested in tea and what does it have to do with the chemistry that I study. So, my interest in the relationship between molecular structure and molecular function is kind of at the core of all of this. Some people would like to know a little bit about the chemistry behind it. What's my big tip for making tea and what does it have to do with the chemistry? Doing these interviews is the crazy part about it is you never know what they're going to ask. And that kind of is a bit like surfing a wave. You have to kind of just, go with the flow. The most surprising question is, why do Americans not drink tea as much as Britons drink tea? And that's something, that's sociology, not something I thought about for the book. But, thinking about it, maybe we're rebelling against our parent country. Hard to know.
Did any of the British outlets know that you've got a son in London?
No. But in fact, in one interview, I guess it was the NPR interview, I wondered if I'm now going to be banned from Britain. Will I be able to, having really dissed, the British and their tea, which I don't think I did, but having kind of interfered with their traditional production of tea, would I still be welcome in Britain? So hopefully, yes.
Is there a question that you wished they had a chance to get to?
I wish they had asked me about the challenges of tackling writing about chemistry for non-chemists. For me, that was maybe the biggest challenge in the book, was not the breadth of the literature or the sort of, how do you figure out, which things you're going to cover, but thinking about how to explain chemistry to people who've not had a chemistry class either ever or in a long time, and in a way that's not just understandable, but also intriguing.
How do you learn to do that?
40 years of teaching first-year students, I think, is probably the answer to that. But they're all signed up for my class. They're interested. And here I had to find a way. These are people interested in tea. So how do you find a way in for that? So the first chapter is called A Cup of Chemistry, and it's got 2 parts to it. One of which is a 3-paragraph thing that has all of the chemistry in it I think you need to know to read the book. And then if you want to know more, there's, another, rest of the chapter that will explain that in more detail. But all of it is tried to link back to things that people know and can touch. So you really want that kind of experience. I mean, I think you had that in Kenya, right? When you took the telescope out, people have looked up at the stars, right? So that's your ramp into the science.
What are the 3 things that you hope everyone knows before they can understand the book?
There's actually 4 things, and I will tell you what they are. That molecular structure and molecular function are related. The second thing is that proximity matters, that things don't react unless they get close to each other. Atoms make up everything. Don't trust them. Atoms make up everything.
Oh, that's a terrible pun. No.
It's a terrible pun. There are several terrible puns in the book, and that's one of them. But atoms make up everything, and it's the rearrangement of atoms. So for example, caffeine is made by rearranging atoms from the detritus left over from damaged DNA. So the plant just recycles damaged DNA using those same atoms into caffeine. And the last piece is that opposites attract and likes repel. So chemists explain a lot of things by electrostatics. And so those are kind of the four big ideas that are at play. And you don't need, a whole chemistry course. Please don't tell my students. You don't need a whole chemistry course to understand it at that level, right? My chemistry course is about all the quantitative stuff. There is, I think, one formula in the whole book, and that's it.
Fantastic. Well, thanks a whole lot in what has become now a ridiculously busy schedule for you to come and chat with us. And last chance, anybody else who wants to, throw a tea bag at you or have any other questions? Dennis.
For me personally, I can drink black tea without feeling any effects of caffeine, but not so with coffee. Is there some chemistry there that explains why one delivery vehicle for caffeine is more effective than the other?
There is a little bit. So there's more caffeine in coffee generally, but also tea contains L-theanine, which kind of moderates the effect of caffeine, not in everyone, but in many people. So often for the caffeine dose, if you had an equal caffeine dose from tea and from coffee, you would find it less energizing from the tea because of the L-theanine.
Okay, and Julie, you had a question.
I think, Michelle, you and I know each other, but never met. You followed me on the Physical Chemistry National Exam, the ACS Physical National Exam Committee. As an undergraduate, I did some research at Argonne National Laboratory with an Irish man, and I would spend time with his family. And as I recall, they made tea by boiling the water, putting the water in a pitcher, adding milk to the pitcher, and then putting the tea bags in, which to me was like, is that something that you've come across?
Yep, and it turns out that if you do that, the extraction of caffeine is reduced. So if you cool the thing down by pouring it into the pitcher as well as adding the milk first, then things cool down and you extract less caffeine total. Even if you let the tea steep longer, you still won't get as much caffeine out. If you go to conferences and they put out those urns of warm water, which those are well below the temperature for ideal extraction. And I think if conference organizers knew they were depriving all the tea drinkers of their caffeine, they might think twice.
Is that why the Brits insist that tea has to be made with boiling water?
It is, and they are correct. I wired all my teapots up with temperature sensors and measured cooling curves. And it's kind of astounding if you don't pre-warm the pot, and if you use like my lovely Japanese cast iron pot, that's got a good strong heat capacity, and boy, the tea temperature drops too fast to get a good dose of caffeine out.
So even that warming up the pot really makes a big difference.
It really makes a big difference. That's maybe the biggest change writing the book has made in my own practice of making tea. Like I just run hot water from the tap in while the water's coming to the boil.
There was something in one of the articles about putting milk in the cup before you pour the tea in. Is that same idea that you're keeping the tea hot and extracting the chemistry, or what?
Yeah. So if you make it with a tea bag, you want to put the water in first and the milk in last, because otherwise it'll cool off too much. If you're going the other direction, you put the milk into the cup and that warms the milk up a little bit, and then you pour the tea in on top of it.
Any other questions before we bid you a fond farewell? This has been fascinating and a lot of fun.
I have a question, if I may, about microwaving tea. In other words, can you comment on the practice, which is, I'm sure, quite barbaric, where you dunk a tea bag in cold water and then stick it in the microwave for a couple of minutes?
Right. Yes, you're right. It is barbaric. And part of the reason it's barbaric is that it comes to the boil so fast you don't get the oxygen out, and that promotes the development of that tea scum. So it's almost impossible to avoid having tea scum if you make your tea in the microwave that way. So yeah, I'm with you on that. Use the kettle.
About the caffeine, how does that work in using this technique? Let's call it a technique.
The good news for most people is that you get the caffeine dose. Caffeine comes out pretty easily. So as long as the water is hot, the caffeine comes out in about 30 seconds. So, if the water gets hot, you've got 30 seconds of that tea bag in there, you're good to go as far as the caffeine goes. You just miss all those nice antioxidants. You miss the nice scented compounds, and you have the tea scum on top.
I think Francis was asking, do you squeeze the tea bag?
The research says you should if you want good antioxidants. It makes it a little more bitter, which then argues for the salt, salt cure, but it definitely gives you more antioxidants. So they suggest dunking the tea bag is a good idea, and squeezing out those, tea bags is also a good idea.
If I'm making tea with boiling water in a tea bag, do I put the tea in the cup and then pour the boiling water over, or do I pour the water in first and then the tea bag?
You're better off getting that tea wet as soon as you can and as hot as you can. So if you pour it in the cup, the cooling has begun. So if you pour the hot water directly onto the tea leaves, you're getting a little bit of a jump start.
But I should warm the cup first.
You should warm the cup first. You should 100% warm that cup first. You'll be happier.
Okay.
So for those of us who live at high altitudes now, would the salt work if you added a little salt to the water so that it elevated the boiling temperature?
Ooh, you would, but I think you have to elevate it by a degree. You have to add
so much.
It's too salty.
Okay.
And yeah, no, the high altitude people, that's tough. I spent a week in Switzerland at about 6,000 feet. And I did notice a little bit of change in the tea.
Thank you very much. Linda, I hope you're drinking tea and not coffee there.
We are.
Good, good.
Excellent.
We just decided, wow, this looks good. Let's drink some tea.
Oh, great. I'm glad I was inviting to do that.
Thank you, everybody, for coming. I should let you go,
Thank
all
you
of
so
you.
much.
Thanks,
And
Michelle.
see you the next full moon.
Great. Thanks so much. Take care, everyone. Have a good cup of tea.
That's a wrap for this podcast. The audio editor for this podcast was myself, Bob Trembley. You can listen to our other podcasts and read our posts on the web at vaticanobservatory.org. If you'd like to attend our full moon meetups and talk with our guests live, join our Sacred Space Astronomy community, also at vaticanobservatory.org. Clear skies, everyone!